Area of a surface of revolution. Before I am reading all that, let me give you a quick example. Let's go straight to the example. So I am trying to graph r equals to cosine theta. You use decimal, you graph r equals to cosine theta, and then you get a circle. So this one we follow the purple, r equals to cosine theta from 0 to pi. That is enough to sketch the entire circle. R equals to cosine theta from 0 to pi, that gives you this circle. That gives you this circle. And then, so we have a circle, right? We have a circle. So what I am going to do is to find the surface area, then I need to find the arc length of this circle. So can you tell me how long this is? And then you have an arc length. So just picture that. You hold up your pencil. You have a pencil with you, right? You just hold up in the air. Can you draw a circle in the air? Just circulate your pencil, draw a circle in the air. We only count the circumference. So that has nothing to do with the area. That has nothing to do with the volume. So no area, no volume. Just hold up your pencil. Draw a circle in the air. Can you picture that? And then why don't you grab this circle and then rotate this circle 360 degrees? Since you have a circumference, when you rotate the circumference 360 degrees, the circumference is just one little line that is like one-dimensional. When you rotate that 360 degrees, you get a surface area. Am I right? Another way to picture this is just put your pencil on your table. And then could you move the pencil left and right really quick? Do you see that when you move the pencil left and right really quick, you just turn one line into a surface area? So this one you can rotate about pi over 2. What is pi over 2? Pi over 2 is right here. We are talking about a polar plane. Pi over 2, then this is like the y-axis of the xy plane. And then if they say rotate about the polar axis, where is the polar axis? The polar axis is right here. So then that will be this rotation. The polar axis refers to x-axis, not refers to, is similar to x-axis. And then pi over 2 is the y-axis. Okay, so let's read this really quick. Let f be a function whose derivative, okay, let's do this again. Let f be a function whose derivative is continuous on an open interval from alpha to beta. From alpha to beta. The derivative is continuous in an open interval from alpha to beta. The area of the surface form revolving the graph. So just revolve this graph from alpha to beta about the indicated line as follows. So if you want to rotate about the polar axis is just like the x-axis, and then this is the integral to find the surface area. Then s is equals to 2 pi from alpha to beta. You have the function times sine, and then you times the square root. The square root of what? What do we have in the square root? We need to square the polar equation, and then we need to square the derivative. So you have a polar equation. You square that, and then you find the derivative of your polar equation, square that as well, and then you add them. So this should be pretty painful when you do the integration because of the square root. That should be pretty painful when you do the integration. And then outside of the square root, you need to take the function, multiply sine. And then if you want to rotate about the line pi over 2 refers to this, just like the y-axis. And then the only difference is you change the sign to a cosine. So that's why I duplicate the same thing and then change sign to cosine. Okay, and then I use a very simple polar equation, r equals to cosine theta. You sketch the graph of this polar equation, and then that is a circle. That is a circle. 0 to pi is enough to sketch the entire circle. And then in decimals, I open up another function, a polar equation, r equals to cosine theta, and I change to red. That is easier for me to follow. And then what I am going to do is, by the way, from 0 to pi, how do you know 0 to pi is the entire circle? That's a great question. How come I don't do 0 to 2 pi? This one, if you change that to a 0 to 2 pi, you get the same thing. But you just trace the circle one more time. How do I know from 0 to pi? Here is how. Using decimal, this is very convenient. So what I am going to do is, I go from 0, okay? And then from 0 to 1 pi over 12. And then you have to change the 1 pi over 12 to 2 pi over 12. And then you go to 3 pi over 12, 4 pi over 12, and then eventually to 12 pi over 12 to sketch the full circle, to make a full circle. So that's why I know from 0 to pi is enough to make a full circle, not from 0 to 2 pi. Okay, so you prepare another graph. So from 0 to 1 pi over 12, you get this, and then 2 pi over 12, you get more, and then you get more. Eventually, it will finish the entire circle. So all you need to do is you just change this quantity. You change this quantity from 1, change that to 2, change that to 3, change that to 4, and then once the graph reach to a full circle, stop, and then you can determine your alpha and beta. So this one is R equals to cosine theta, alpha is equals to 0, and then beta is equals to pi. Let's do the revolve R about pi over 2. Then we will follow this formula. Okay, let me just copy this formula. I'm going to do a copy and then paste that over here. We can make that smaller. And then my integral is, let's do that. So I have S equals to 2 pi. And then from alpha to beta, from 0 to pi. Okay, this number looks pretty easy. And then what is my function? My function is cosine theta. And then in purple, this is times cosine theta. And then you have a square root. And then a d theta. Okay, R is equals to cosine theta. R square is equals to cosine square. And then the derivative, we can do dr d theta, that is equals to the derivative of cosine is negative sine. And then you square that, dr d theta square. If you want to be less fancy, you can do r prime and r prime square. That is equals to sine square. Okay, wow, perfect, nice. I like this. Cosine square plus sine square. It looks like I can get rid of the square root so easily, right? Cosine square plus sine square is equals to 1. So that is equals to 1. The square root of 1 is equals to 1. Okay, perfect. Then the surface area is 2 pi from 0 to pi. And then this is a cosine square theta d theta. Don't laugh right now because you cannot integrate cosine square. You cannot integrate sine square. You cannot integrate cosine square, one term at a time. So when you see sine square or cosine square, you have to use the power reducing formula. That will be cosine square theta equals to 1 plus cosine 2 theta divided by 2. This is called a power reducing formula. If notes is allowed on exams, you may want to put this on your notes. Power reducing formula. Okay, and then next step, we have a 2 pi integral from 0 to pi. Let's put this down. Can I take the 1/2 out? 1 plus cosine 2 theta, and then d theta. And then the 1/2 cancels the 2. I have a pi. And then what about the integration? Integral of 1 is theta. Integral of cosine is sine. I have a sine of 2 theta. Can I just go from 0 to pi? Did I miss anything? Yes, I do. Because when you take the derivative of sine by chain rule, that creates a 2. Because the derivative of 2 theta is equals to 2. I need to prepare a 1/2 to get rid of the 2. And then now we do the plug-in. Plug in a pi. This is a pi plus 1/2 sine of 2 pi. This is great. Sine of 2 pi is 0. Minus pi, plug in a 0. 1/2 sine of 0 is also 0. So that is a 0. And then sine of 2 pi, that gives you a 0. And then this one is a 0 as well. So all the work after all this for a pi square. So this is for a pi square, then that is your surface area. What is this surface area look like? So once again, pi square is your surface area. What is the surface area look like? You have a circle. You have this circle, and then you find the arc length, which is the circumference, and then you rotate your circumference 360 degrees. I will say that looks like something look like a donut, but you are not looking for the volume. You are looking for the surface area of that donut. All right, so that is the end of this video. If you like it, give me a like, subscribe to my channel for more contents like that. I will meet you all in the next video.